Okay, so we're going to solve systems using substitution. Okay, and the reason it's called substitution is, what does it mean to substitute? Like, what is a substitute teacher? A replacement, right? So we're going to replace part of the equation with part of the other equation. So in this first one, because one of our lines, and we looked, this is actually right off of this graph here. One of our equations was x equals 2. That's a pretty simple equation. I'm just going to take that 2 and I'm going to substitute it into the other equation for x. Okay? So this is going to be symbolically where the two lines meet. So that'll transfer to, and write this in your notes, that'll transfer to y equals negative 2/5 times 2 plus 4. Okay, so instead of the x, I'm putting in the 2 from the other equation. All right, and from here, we get to just find out what our y equals. We can just solve this. We can simplify the right side of this equation. So negative 2/5 times 2, okay, that's going to be a negative 2 times a positive 2, which is 4, and then plus 5. Well, you guys figure out what's negative 2 times 2 divided by 5. Or you could take negative 2 divided by 5 times 2. What do we get? Negative 0.8 plus 4, right? Because the negative, or the 2/5 was negative. Okay, now what is negative 0.8 plus 4? What is it? 3.2. So that means y is 3.2. That means when these two equations meet, y is 3.2. And if we can look here, we estimated from the graph that it was 3.25. So we were really close if we would just take off that 5. Okay? And from our graph, or from our equation, we know that x is going to equal what? 2. Right? X is always going to equal 2 because one of our lines only goes to 2. One of our lines only hits 2 all the way. Okay? So in a system of equations, you always need a solution. So in your notes, we write down the solution to this system is going to be x equals 2, y equals 3.2. All right? That's one type of problem that you might solve symbolically. Okay, so our two equations for number 4 were y equals x plus 5 and y equals negative 3x plus 3. Okay, again, I'm going to use substitution. Okay, this time, instead of substituting just one thing, I'm going to substitute x plus 5. What does x plus 5 equal? Y. So I'm going to substitute it in for this y. Okay, and that's going to look like this. If we go over here, that's just going to look like x plus 5 equals negative 3x plus 3. Okay? And then from here, this is just like our daily math. This is just like solving equations. So we don't have any parentheses to get rid of. We do have a variable on both sides. So which one are we going to get rid of? Variable. Which variable? How are we going to? Which x are we going to get rid of? The lower one. So negative 3. So I'm going to add 3x to both sides. And then that's 4x plus 5 is going to equal, that crosses off, and that equals 3. Then I'm going to subtract 5 from both sides. This should all be going in your notes. That's going to cancel. And 4x is going to equal negative 2. Then I'm going to divide by 4. And x is going to equal negative 0.5. Because negative 2 is negative 1/2. So negative 0.5. Okay, so we're looking at a system here, so we're going to have a solution. We've just figured out that the x in our solution is going to be negative 0.5, okay? But we have to figure out the y. So when you don't have, in that last example, we had just x equaled 2 all the time, so that was really easy. We knew x was going to equal 2. When you don't have something like that, you have to sub in again, and we're just going to put this negative 5 in for either one of these two x's. And both times we'll get the same answer. So if we do this one, y is going to equal negative 0.5 plus 5, which equals 4.5. And if we do this one, y is going to equal negative 3 times negative 0.5 plus 3, which is also going to equal, guess what? 4.5. This is where we talk about the solution to a system of equations, is when you have the same input. When we input negative 0.5 into both of these equations, we get the same output. So in this system, the two lines should meet at negative 0.5, positive 4.5. And if we look back on our graph, that's where they met. Okay? So that's the second type of equation that I want to talk about when talking about solving equations. The third type, we didn't graph, but we looked at similar ones yesterday when we were doing Khan Academy problems. Okay? We had problems where we had something like negative 2x plus 6y equaled negative 30, and x plus y equaled negative 1. This is kind of like that problem that I set up at the beginning of the class, where adults and children went to the amusement park. Okay? So we don't necessarily have like a rate of change or a starting point or anything like that in some of these equations. We can, however, change one of these equations to be a y equals. Okay? But sometimes you'll set up a system that won't really be in slope-intercept form. We call this standard form. So what we need to do is we right now don't have one variable by itself. We can't substitute one thing in for the y's or one thing in for the x. So we need to create one variable by itself. And I'm going to do that with this equation because it looks really easy for me to get either x or y by itself. Okay, so I'm going to change this equation to y equals negative 1 minus x. Will you tell your partner why are those two equal? Why is that the same equation? Negative 1 minus x. What did I do to get from this equation to this equation? I moved the x. How did I move it? Did I multiply it, divide it, add it, subtract it? I subtracted it. All I did, guys, was I subtracted x from both sides of this equation. And x minus x is 0, so that went away. And negative 1 minus x can't really be done, so it turns into negative 1 minus x. And now the benefit of this is that negative 1 minus x equals y. So I can take that and I can substitute it in to this y in the other equation. And that will represent where these two equations meet. So once I do that substitution, here's what happens, and this should go down in your notes. That negative 2x stays there. And then 6, instead of being times by y, is going to be times by negative 1 minus x, all in parentheses because that's all y. Okay, so that needs to go down in your notes. And then from here, again, like solving equations, Abby, you got this down? We just solve. Okay, so first we're going to have to distribute. We remove parentheses. What's 6 times a negative 1? Negative 6. What's 6 times a negative x? Negative 6x is going to equal negative 30. Okay, to add like terms or combine like terms, what's a negative 2x and a negative 6x? Negative 8x, and then minus 6 is going to equal negative 30. I'm going to add 6 to both sides. Okay, and then I'm going to divide by what? Negative 8. And what's a negative 24 divided by a negative 8? Positive 3. So x equals 3. So in my solution, I'm going to have x equals 3. Do I know y? Do I know y yet? No. Again, then, I need to plug in this x equals 3 into either one of my equations. Both will give me the same answer because this is the solution. I'm going to plug it into this one where y is already by itself. So that gives me y equals -1 minus 3. And what is -1 minus 3? -4. So my solution here is 3, -4. That's my answer to the system. That is where these two equations will cross. That's where their two lines will meet. Okay?